In August 2005, Hurricane Katrina came roaring into New Orleans. 17 years later, Katrina is still one of the deadliest hurricanes to ever strike the United States, killing nearly 2,000 people. It's also the hurricane that has done the most financial damage in the US, almost $200 billion worth. Katrina, other storms and weather events, are often referred to as natural disasters, but
I cringe when people use the term natural disaster. In academic fields, and particularly in the hazards arena, there's a real resistance to use that term because it basically dismisses the fact that there is human agency and that people make decisions about living in harm's way.
that's Craig Colton, professor emeritus of Louisiana State University's Department of Geography and Anthropology, who we chatted with for this episode. When Katrina hit, he was in Louisiana.
We knew long before Katrina, for years before Katrina, there had been, after 2000, there were two or three big mentions, big articles in the Times-Picayune, the New Orleans newspaper, about the fact that a big one was coming. It was kind of like you hear the stories about the big earthquake in California. We had the same thing about a devastating hurricane in Louisiana.
So, if we knew Katrina was coming, how did things still go so wrong? Welcome to Tiny Matters. I'm Sam Jones, and I'm joined by my co-host, Deboki Chakravarti.
Today on Tiny Matters, Sam and I are going to talk about environmental disasters. But as we were planning this episode, we realized that this was a topic that is really broad because there are so many different types of disasters and so many different aspects to them. So this is going to be a two-parter. Today, we're going to focus on Hurricane Katrina, as well as the Ohio train derailment that happened earlier this year. We're going to talk about the science underlying those events and why they happened, as well as what we've learned from them. And in the next episode, we're going to cover the Deepwater Horizon oil spill back in April 2010 so that we can focus more on the challenges scientists face sharing their findings during these crises. So for now, let's go back to Hurricane Katrina.
As you heard Craig say at the top of the episode, calling a horrific event like Katrina a natural disaster removes human responsibility. Not just the fact that human driven climate change has led to an increased number of these events and their severity, but also the way that hazards like floods, heat waves, and hurricanes become bigger disasters because of societal vulnerabilities. Social, political, and economic status all play a role in where we live and the resources we have to make those places safer. People who are poor and in marginalized communities are disproportionately affected by these disasters.
So let's set the scene in New Orleans before Hurricane Katrina arrived. In doing research for this episode, we came across a story in Scientific American written by journalist Mark Fischetti in October 2001, just shy of 4 years before Hurricane Katrina wreaked havoc. He writes, quote, "New Orleans is a disaster waiting to happen. The city lies below sea level, in a bowl bordered by levees that fend off Lake Pontchartrain to the north and the Mississippi River to the south and west. And because of a damning confluence of factors, the city is sinking further, putting it at increasing flood risk after even minor storms."
For those of you like me who knew nothing about levees before hearing about them in the context of Katrina, they're human-made walls or embankments, which are essentially mounds of earth that are designed to hold back rising water, whether that be the constant rise and fall of a river current or a massive flood caused by a storm. With Katrina, the levees didn't hold.
But we weren't ready for this, and it overwhelmed the human-made fortifications. And it was the failure of those human-made fortifications that made it truly a disaster. Without those being there, it would have been a mess, and it would have been horrendous, but it wouldn't have been as horrific because the flooding probably wouldn't have been nearly as deep, and much of the city wouldn't have subsided as low as it had since the levees were built and the city was drained.
What do you think our listeners should know about Hurricane Katrina before we talk about the levee construction?
Well, there had not been a really major hurricane that swept over New Orleans since 1965.
That hurricane was Hurricane Betsy, which hit Louisiana on September 9th, 1965, and caused between 70 and 80 deaths. It was the first Atlantic storm to produce over $1 billion in damages, which would be over $9 billion today.
You have a lapse of 40 years, and so there was a certain sense of complacency. So the hurricane was coming. We had much better tracking of this hurricane. 3 or 4 days out before Hurricane Betsy, they were predicting a hurricane disaster zone that stretched from southern Texas to western Florida. This one, 72 hours out, they had just a remarkably accurate path portrayed. So the science of tracking hurricanes has gotten much better, but it was a big storm.
Katrina formed over the Bahamas on August 24, 2005, continuing to track west while gradually intensifying, making landfall along the southeast coast of Florida on August 25th as a Category 1 hurricane.
It hit Florida and then came over the Gulf, and the water of the Gulf was very warm that year. It intensified the storm, and it came barreling in towards New Orleans. And one of the takeaways from this was it wasn't the wind speed. This was not a wind-damaging storm as much as some storms, but it was a storm surge.
Hurricanes form as warm, moist air over the ocean rises upward, creating a low-pressure system. In other words, there's less atmospheric pressure holding the water down, so the water carried by the hurricane actually rises in height. This is a storm surge. And compounding that, you have winds making giant waves. The track of the storm came right up the mouth of the Pearl River, which is the boundary between southeast Louisiana and southwest Mississippi, and powerful winds then pushed Lake Pontchartrain, an estuary bordering New Orleans, over the levee system.
For people who don't know much about levees or a levee system, as you know, I'm one of those people, before the storm hit, why was that levee there and how big was it?
When the French settled in Louisiana in the 1700s, they began building levees in the 1720s, and they required landowners to begin building levees along the Mississippi. Along the river, they built levees on both sides, and they were 4 feet high first, and they rose up over the years. And then when the federal government took over responsibility in the 1870s, they gradually rose to about 20 feet high, 20 plus feet high at New Orleans.
The first real hurricane protection levees were built following a hurricane that hit Louisiana and Mississippi in 1915, slamming into the coast with 120-mile-per-hour winds, killing hundreds of people and leading to $13 million worth of damage, the equivalent to nearly $400 million today.
The first levees were built just to protect New Orleans, not the adjacent suburbs, which weren't really very big then. After Hurricane Betsy in 1965, this was post-World War II, the city was sprawling. You had post-World War II suburban sprawl, and the city had grown into adjacent Jefferson Parish to the west, and had been growing into parishes to the south and east of the city. Those were areas that suffered the worst flooding in both 1947 and 1965. So then, after 65, Congress appropriated funds, and the Corps of Engineers began rushing forward with building more levees. These were levees that enclosed the city on all sides and connected with the river levees. You already had this really formidable levee system along the riverfront. And then they built these, what we call back levees. That system was started in 1965, and it was not complete in 2005.
If they had been finished, do you think there would have been less devastation, or was this something that even the levees would not have been able to really slow down?
Some areas were definitely damaged because of the incomplete nature of those sections. Other sections failed because of design flaws, levees that under pressure, they just bulldozed forward. There was so much water pushing up against them. The levees themselves acted as giant bulldozer blades and pushed the land several feet, and then they collapsed and allowed flooding into the city. Much of New Orleans is below sea level, and it sank after the levees were built because of subsidence. They were designed to protect the city, but then once the levees break, they hold the water in, particularly in those areas that are below sea level. You couldn't drain it out. You had to pump it out. So that exacerbated and accentuated the problem of flooding.
What are the things that stand out to you most in terms of immediate impact of this hurricane and the levees breaking?
Well, several things. I mean, one, the first thing is they did do a remarkable job of motivating people to evacuate till fewer people were in harm's way directly. But the storm damaged over 100, seriously damaged over 100,000 houses. Something like 40% of the city was underwater. Some places were up to 2, 3 weeks. And then with Rita coming shortly thereafter, floodwaters came into the gaps in the levee again.
Hurricane Rita touched down just a month after Katrina, and like Katrina, was a Category 3 hurricane.
So you had tremendous property damage, people displaced for long periods of time, businesses were damaged and destroyed, and it took years to rebuild all those facilities. It caused a giant leak at one of the refineries in a suburb downstream from New Orleans in Chalmette. So you had properties covered with floodwater and oil.
Schools were closed, many people were forced to leave, and tourism shut down for a while. People's livelihoods and the local economy took a massive hit, and that affected poor Black people the most. In a report by the Congressional Research Service that came out on November 4th, 2005, Black people accounted for 73% of the people in New Orleans displaced by Katrina, and more than 1/3 of those people were estimated to have been poor.
I think a lot of times when there's a crisis, people are trying to find out what's happening and provide information as quickly as possible. And it doesn't always go incredibly well. And so I'm curious, were there things that you felt like you were seeing misrepresented at the time?
Well, a lot of smaller towns have lost their local radio stations. You just don't have them anymore. People can turn to the internet, you can get media, but it's not local. So you don't have people on the radio locally who know the community and can take phone calls and report the news. So we have what I call panic radio, and these morning talk jocks would do programs, and they'd take calls from people, say, "Oh, if you would call in pleading for information on their relatives who lived in this community or that street or that neighborhood." It fueled panic. It did not serve any real purpose. So I think that could have been moderated with some more local communication tools. But I think too, in terms of communication, in the long term, how do we, sustain the memory of an event? We proposed going through the city and putting marks on telephone poles or street lamps that showed the flood height during Katrina. And that was resoundingly rejected. And I understand their resistance to having a reminder. But in European cities, there's always a bronze bar on the church where the record high flood mark. And there's a lot of interesting work being done on flood memories. How do you sustain memory so that people remember this is something that can happen? This is how high the water stood after Katrina. New Orleans developed a big hurricane plan, as did the suburbs. In 2012, Hurricane Isaac struck, and one of the neighboring communities said in their after action report, they didn't even bother opening the binders of their plan that they developed in 2006. So there's always a search for lessons learned, but are these lessons retained is the big question.
Today, it's been about 17 years since Hurricane Katrina. What are some of the lasting impacts that you see?
There are still places that are not back to normal. I mean, there's still areas in New Orleans East and places like Chalmette, the downstream suburb. You see these giant gaps in the neighborhoods. After the storm, there was a lot of talk about rebuilding the city, and the city went very aggressively towards rebuilding areas that were severely damaged rather than concentrating construction on the safest areas. And so they've rebuilt a lot of areas that are in these below sea level locations. Those areas are still susceptible. New Orleans still needs to improve its drainage system, even without levees breaking. If you had a Harvey, which dumped 60 inches of rain in Houston, New Orleans would be 2 or 3 feet deep in water, even in some of the higher areas, probably. I think there's general awareness in the state. People generally prepare for hurricane season. It's pretty well. And we've had several big storms since then. There was a lot of talk when Ida hit, in 21, that the levees saved the city. Well, it wasn't the same storm. It probably didn't even test the levees. The city was not flooded. The levees worked. but it wasn't the test that Katrina would have put on them. So we don't really know if it will protect the city against a comparable storm. The impact of Katrina weren't the result simply of Katrina. We'd had major storms in 1947, 1965, and 2005. And in each of those storms, steps were taken, lessons learned, but then lessons lost. And there was always an emphasis on rebuilding the city for the local economy, and safety was always given second consideration. The thing that troubles me most about the recovery is that economic prosperity for those in a position to benefit from it was prioritized over making the city really safe for everybody.
Now, Sam and I are going to fast forward to a recent event, the train derailment in East Palestine, Ohio on February 3rd of this year, where a train carrying hazardous materials derailed. Of course, compared to Katrina, no one could try to chalk this up to being a quote, natural disaster.
One of the bearings on one of the railroad cars overheated, causing a derailment.
That's Hans Plug, a toxicologist with Safer Chemical Analytics LLC, who has been an environmental consultant for over 40 years, working on toxicology reviews for a huge range of chemicals. When the train derailed, there was a lot of confusion on everyone's part. First responders, like firefighters, didn't have much to go off of. There weren't safety data sheets available on the train telling them exactly what chemicals were being carried. And some train cars were already on fire. Hans told us that the responders were, justifiably, most concerned about something called a BLEVE, which stands for Boiling Liquid Expanding Vapor Explosion.
Basically, once you have a vessel that you heat up and it contains a chemical that can become volatilized, pressure builds up extremely quickly, at which point the whole thing explodes.
So essentially, when it goes from liquid to gas, then you have an intense pressure buildup in a closed system. I mean, it's really like a bomb, right?
It has a release valve, but basically there's no release valve made in the world that can release it fast enough, because basically they're set up for a small amount of pressure, not, when it heats up outside to 120 degrees. Levees are disastrous.
BLEVEs can create large fireballs that spread and radiate heat. Hans told us that if there had been a BLEVE, much of East Palestine could have been demolished.
So the standard technique at that point is to puncture the tanks, let them burn naturally, and then go back in and extinguish the flames once the stuff has burned out sufficiently.
So now let's get into some of the misinformation that was spreading at the very beginning of the crisis, particularly regarding vinyl chloride. Vinyl chloride was one of several chemicals being transported by the derailed train. It's used primarily to make polyvinyl chloride, PVC, a hard plastic resin used in a bunch of different products like pipes, packaging material, and wire and cable coatings. Workers at facilities where vinyl chloride is produced or used have an increased risk of a very rare form of liver cancer called hepatic angiosarcoma.
So, vinyl chloride is a carcinogen, but over time, super short term exposure to vinyl chloride isn't a concern. It actually used to be used as anesthesia many decades ago. But following the derailment, vinyl chloride received a lot of attention, particularly when, to prevent a BLEVE, responders released it from the tanks to burn. So we asked Hans what happens to vinyl chloride when it burns.
It mostly goes into hydrochloric acid, basically your standard acid, HCl. Not chlorine gas, but hydrochloric acid.
I saw a lot of confusion about this in the press, where you might have seen reports about chlorine gas being released as the vinyl chloride was burned. Like Hans said, chlorine gas was not being released, hydrochloric acid was. This is an important distinction to make. Chlorine gas is corrosive to the eyes, skin, and respiratory tract. And at high concentrations, it can be deadly. It was used as a chemical weapon by German forces in World War I. But chlorine gas is made up of two chlorine atoms bound together. What was being released was hydrochloric acid, which is a hydrogen atom bound to a chlorine atom. It behaves differently than chlorine gas, but it's still not something you want to breathe in.
causes upper respiratory irritation in high concentrations. Generally speaking, unless you are exposed to a really high concentration for a long period of time, the effect tend to be transient on most people.
What are some of the health concerns that people have who are in this area? Because there are other chemicals of concern that were released into that area that are not vinyl chloride. A couple that I read were ethyl hexyl acrylate and ethylene
Yes.
glycol monobutyl ether.
Well, the first one is a crazy glue ingredient used for a lot of adhesives. The second one is what goes into latex paint to make it work as paint. So that exposure to that is fairly common, generally speaking, if you use latex paint.
There did seem to be concern about some chemicals that have been detected in the Ohio River since.
Yes. Anytime you have a spill, you're going to find chemicals in the water streams around there. Part of that is because after things had sort of finished burning, they wanted to cool them off to be able to get there. So a fair amount of water was put on top of the burning vessels to cool them down so they could be touched and investigated. So yes, there was a lot of runoff.
Hans told us that fortunately, a lot of that runoff was contained on site, but there were definitely releases into the river. Unfortunately, it's hard to say how much.
The problem here is that these chemicals are unfortunately present in the environment at certain concentrations. So detecting it on and off itself doesn't indicate that there was exposure or spill.
They're present in the environment at a base level because of other stuff that we're doing, like other industries and things.
Yeah, I mean, people dispose of their latex paint can in trash. The trash gets into a landfill that's not lined. It leaks into the groundwater. The groundwater goes into the river, etc.
So you're probably wondering what's going on at the derailment site now. A number of things, but a lot is still unfolding, and investigations into exactly how this happened are ongoing. The Ohio and Federal Environmental Protection Agency and the railroad company involved, Norfolk Southern, are continuing with cleanup, including soil removal at the derailment site and air monitoring of the work zones and surrounding community. The CDC is continuing to hold public health information sessions in East Palestine, although Hans notes that having that kind of communication right at the beginning of the disaster could have been more impactful for people.
At this point, a big question that remains is how is trust rebuilt in this community? Surveillance, epidemiological studies, and transparency surrounding health impact and cleanup processes feels like a start. Hans told us that another important step forward is to put into place regulations that should have been there from the start. For instance, having hazardous materials separated by multiple train cars so that 10 cars all carrying hazardous materials aren't tightly grouped together. That way, if something goes wrong, you're not worried about a massive explosion. Plus, the very simple thing of making it easy for a first responder or train worker to find out exactly what the train is carrying so that no one has to play guessing games during a crisis.
Rebuilding trust is hard, not impossible, but of course, it depends on the choices we make and how we communicate with people. On the next episode of Tiny Matters, we're going to focus a bit more on those choices and how they shaped the response to the 2010 Deepwater Horizon oil spill.
Let's do our tiny show and tells.
I can go.
Okay, sounds good.
This is one that I didn't mean to be related, but it kind of is related because it could have been a disaster, except that luckily space just doesn't have the microbes that we were afraid it was going to have. So in 1969, astronauts were coming back from the moon, right? They were on Apollo 11, they were coming back. But NASA wasn't sure about how to handle the fact that we didn't know what was on the moon, right? We didn't know if there were microbes or anything else bad for us that could come back with those astronauts. So they decided to quarantine just about everything and everyone who had come into contact with the moon. Luckily, they also have archives of materials for us to look back on those things. So, an environmental historian from Georgetown University wanted to see how useful that quarantine was. So, he looked through those archives. And overall, he found that the protocol they followed wasn't really needed. But if there had been any lunar germs, that quarantine would also probably not have been super effective. It is important for us to be looking back to see, were these quarantine measures needed? Like, how effective would they have been if there was anything going on? Because we are still looking to bring samples back from space. There's a whole mission going on Mars about, bringing samples back, hopefully, so that we can study them for potential life on Mars. So, the big picture message, though, that this paper drew from looking from these archives is that, and I'm going to quote directly from the New York Times article on this paper, this is an example of the tendency in scientific projects to downplay existential risks, which are unlikely and difficult to deal with, in favor of focusing on smaller, likelier problems. And so we created these quarantine methods because we knew that this was something that we could do. But like there's this bigger existential question of what would have happened if microbes came on Earth that like we weren't necessarily prepared for. And digging through the archives like revealed other things too, like that the quarantine facility had issues. There were cracked or leaky autoclaves and glove boxes. So like overall, it just didn't sound like it would have been very effective. At one point, 24 workers did end up getting exposed to the lunar material and had to be quarantined. So there are a bunch of ways that like this could have been a problem. And so the reason that I was curious about this was both because I find this whole quarantine thing like kind of fascinating to learn about, but also because as this article is talking about, this extends beyond this one particular field. This extends to things like AI and climate change, this tendency to focus on the threats that feel like they have lower consequences because they're more manageable, and then minimizing the existential problems that could arise that we just don't want to deal with because they're so much harder.
So it's really like what needed to happen or what needs to happen is things that have not really been developed yet. The
Yeah.
time has not been put into actually developing things that really could make a difference.
Right.
That's interesting. Well, thanks for sharing that. I always think any sort of like archival stuff is very cool.
Of course, yeah.
My tiny show and tell is pretty brief. It's about an important anniversary. So, a decade ago, on June 13th, 2013, the US Supreme Court ruled unanimously that human genes that are isolated from the body cannot be patented. This is really important because it means that companies couldn't just patent a random naturally occurring human gene and saying, like, we're the only ones that can make a test for this gene mutation that's naturally occurring. The reason that this whole case came about was because of patents held by Myriad Genetics, which is a Salt Lake City firm that had been granted patents on two genes that I think are pretty well known now, which are BRCA1 and BRCA2, that can lead to an increased risk of breast and ovarian cancer. And so they were using these patents on these genes that are naturally occurring genes in the human genome to become the only US commercial supplier of genetic tests for those cancers. And it was very expensive, as things are usually when they are patented and there becomes this monopoly. And so, with this ruling by the Supreme Court on June 13th, 2013, it invalidated those patents and really changed the game, I think, in a lot of ways in terms of sequencing the kind of information that people can be given about their health and making it so that one company doesn't hold a patent and then everyone has to go through them, which means they can jack up the prices, et cetera, et cetera. We know how this goes.
Yeah, that's such a good thing to highlight. And first of all, I realized that like we're both in like a real history mood today. But then I had this moment of like, I can't believe that we're thinking of like 2013 as like history.
Yeah. I just thought it was so interesting and just thinking about what can companies have ownership over. You can modify a gene and that is patentable. But just
Yep.
saying, hey, this gene that is naturally occurring, we're going to patent a test for that. Like you can't,
Yeah.
that's not a thing. You can't do it.
Yeah, imagine how different things would be if that ruling had gone differently.
I know.
Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society. This week's script was written by Sam, who is also our executive producer, and was edited by me and by Michael David. It was fact-checked by Michelle Boucher. The Tiny Matters theme and episode sound design are by Michael Simonelli and the Charts and Leisure team. Our artwork was created by Derek Bressler.
Thanks so much to Craig Colton and Hans Plug for joining us. If you have thoughts, questions, ideas about future Tiny Matters episodes, send us an email at tinymatters@acs.org. And if you'd like to support us, pick up a Tiny Matters coffee mug. We've left a link in the episode description. You can find me on social at SamJScience.
And you can find me at okidoki_boki.